Okay, we're working with equations, and what we want to find out is if our I don't know is a solution to a system. And so let me make this large here. Let me show you what I mean. So there's an I don't know that's involved now in an equation. We've got this where we have I don't knows involved, and we want to first just see, our first step is, does this solve it? And what that means is if I put 3/2 in for x, anywhere there's an x, does that turn out to make this true? Let's try it. So wherever I had an x, I'm replacing it. And when you replace it, put it in parentheses, you're subbing it in. Now let's try to just tidy this up. We can reduce these here. 2 times 3 is 6, minus 2. We can reduce those there, I get 3. Remember how your fractions work. 4 times 3 over 2. That gets me, and then we can just multiply the tops. Do you remember this? This gets you 6. Same thing over here, we get a 3. So when we tidy this up, I get 4 equals 4. That's true. That makes this a solution. Now you can always pause the video if you want to try it yourself. I'm going to work this as well. I'm going to put 4/3 in here. So I've got 9 times 4/3. Put it in parentheses to say I've subbed it in there so I don't lose any math that needs to be done. Okay, now if you're rusty on your fractions, it's like 9 and 1, so we're going to reduce that. That gets me 12 over 1, which is just 12. Going to reduce this. It's like 2 times 4, that's 8 over 1, or just 8. Now I get 14 over here and 11 over here. This is not a solution. So I've subbed in that value for that I don't know, and this does not tell the truth, so that is not a solution. Okay, pause and try this one if you'd like. Okay, remember I can cancel those, so it's really like over a 1. Gets me 7 plus 3. Over here I can cancel those, get a 2. It's like a 14. So I get 10 equals 10. That is true. So y equals 7/5. That is true for y. That is a solution. Okay, so now we're going to start working with solving equations. And I want to make you this little balance here. So suppose we are balanced, and let's say that this equation is equal to each other. That means my balance beam is staying even, it's perfectly even. Well, if these are kilograms over here, and I take 5 kilograms from one side, as long as I take 5 kilograms from the other, these are going to remain to be in balance. And that's what this property is. You could add 5 to either side, you could subtract it, and as long as you stay in balance, it's going to be fine. So what I mean is this, we're going to take away 37 from this side. But if you do it to one, you got to do it to the other so that we keep an equilibrium, that we keep it equal to each other. Now that's going to eliminate everything over there on the left, but what about on the right? You owe me $13. I'm taking away 37 more. Y is negative 50. Now they've got a check here, but we've solved this correctly. That's going to prove to be correct, but if you wanted to check, you could put that in and see if you got the right value. Okay, now we're going to do the same thing again. We want to remove 19 from this side, but if we do, we have to remove it from this side. Okay, well, nothing is left over here now but x, so that's good. Now, you owe me 27, you owe me 19 more. So there's a couple ways to do this, but what you could do is just add them up. If you don't see those numbers, we're going to get 46, but you owed it to me, so it's a minus. Okay, let's take away 16 from both sides here, but you keep it in balance. All right, you owe me money, you owe me more. You can work this over here by just putting them together and know that it's going to be a minus when you're finished. And you get 50. So minus 50 because you owed me the money, you owe me more. Okay. I think we've already said that. I don't know where they're going with that. Oh, they're just saying subtraction, addition, doesn't make any difference. So we wanted to take away from each side. Well, what if we now add 28 to both sides? It's not going to change anything. It's going to do the same exact thing. We'll have opposites here. So as long as you're doing it to both sides of your balance beam, it'll be fine. So we get rid of the 28s over here. Now we have opposite signs here. So you owed me 37, but things are getting better. It's now 28. Now if you're not sure how to do that, when you have opposite signs, you just subtract them. And you take the sign of the bigger one that you started with. That was a 9, so positive 9 or negative 9. So let me say it again. I have two different signs, so I'm going to just subtract them. And then you give it the sign of the number that was bigger when you started. So it was a negative 37, so I'm going to give it a negative 9. Okay, let's add 61. But if you do it to one side, you've got to do it to the other. Now those are opposites, so I'm going to have n equals. Now if you don't see it again, so I owed money but things are getting better, so I'm going to subtract the two of them. I've got 14, but I'm going to give it the sign of the larger number. So when I started, my larger number was the negative, so negative 14. Okay, more of the same. You can always pause the video if you want to try it on your own. Okay, those will cancel. I'm left with P equals over here. Now again, I don't see this in my head, so I'm going to come over here, and they're opposite signs, so I'm going to subtract them. Now, the larger number when I started was the negative 73, so I'm going to make that negative 32. So we're going to take the sign of the larger number that we started with. Okay, let me see. Are they going to do this trick? No, they're not. They're going to leave it. Okay, there's a trick to clear this out, but I don't think we're quite ready to tackle that. What they're saying is here, don't be afraid that this is a fraction. That doesn't change a thing. I want to add 5/8. Now I know no one's comfortable with fractions, but there's nothing wrong with that. I can just add 5/8. It's just a number. But if I add it to one side, I've got to add it to the other. Now these will cancel. Now this will be x on this side, but let's see. Do you remember how to put these fractions together? I need the slices of the pie to be cut the exact same way. So they both need to be sliced as their what's called their least common denominator. I need to make them both an 8. Okay, this was already 8, so that's fine. I can just bring the top down, but this wasn't. To turn from 4 to 8, I had to multiply by 2. If you do it to the bottom, you got to do it to the top. That makes a 6. Okay, now they're the same sliced pie. The 8s are the same. You can just add up the tops and keep the bottom. So x is going to turn into 11/8. Alright, you try one if you want to pause it. We're going to add 2/3 to that side, which means we have to do it to the other. Now let's come over here. We've got 5/6 and 2/3. I need them both to be over the same thing. And I could turn them both into 6, so I'll do that. This one was fine, so I'll just leave that alone. But this one I had to multiply the bottom by 2, so I've got to do the same to the top. Okay, now the slices are the same. The 6s are the same on the bottom, so I can just add these up and get 9/6. So P is left alone over here. Those canceled. Okay, now do you remember that both of these are divisible by 3? So I could reduce this down to 3/2. And I'm done. Okay, try this one. We're going to add a 1/2. I need a common denominator. So to change that over, I had to multiply by 3 on the top and the bottom. Now, the bottom's the same, so I'm ready to go. I can just add the tops to get 8/6. So Q equals, because those canceled, 8/6. Now, these are both even numbers, so I could divide 2 into both of these, and I get 4/3. Okay, let me see what we've got here real quick. Okay, we're working with some decimals here next. Okay, so we're going to add, let's see how they did with this. We're going to add 0.63 to both sides. Okay, now the math here might be a little tricky for you. We're adding the 0.63, so we have opposite signs over here on this right, so we're going to subtract these. Okay, now let's add a 0. Remember how to do this? We're going to have to borrow. Gets me 7 there. But I stole from this too, so I'm going to have to borrow here as well. That's going to get me 5. So I get 3.57. Now, the larger number was the negative, so it's going to be a negative. And there's our answer. All right, I'm going to add 0.47 to both sides. Now these will cancel and I'll be just left with b, but we have to come over here and add negative 2.1 and 0.47. So let's do it. They're opposite signs, so we're going to subtract them. I'm going to borrow. Give me a 3. Borrow again, I get 6. I did something wrong. I paused it because I was convinced I had messed up, but I didn't. Okay, so we're adding 47. Let's do it again because I thought I did my numbers wrong. Okay, so they have opposite signs, so I am going to subtract them. Okay, so we had to borrow. Gets me the 3. Got to borrow again. Gets me the 6. So I got 163 left. Now they were opposite signs, so let's take the sign of the larger one, which was the minus. And there we go. Okay, always pause if you want to. We're going to add 0.93 to both sides here. So they're opposite signs. We're going to do what we've been doing. We're going to subtract them over here. Okay, let's borrow. That'll leave me with a 7. Now we got to borrow again. We get a 6. All right, 367. However, the larger number was the minus, so we're going to have C equals negative 3.67. Okay, now we have got to do some cleaning up here before we can just solve this. So what we're going to have to do is combine the things that are alike. And so it's called combining like terms, and x's and numbers are not the same. So I've got 9 guys on the X team, 8 guys on the X team. That's the same team. The name of the team, the variable part is the name. And then we have how many guys are on that team. So I can combine 9x minus 8x. They're on the same team. So when you put those together, you're left with 1x. You've got 1 guy on the X team. And now the numbers, they're not on any team. We can just put them together. It's minus 5 and minus 6. So things are getting worse. You owe me 11. So x minus 11 equals 7. Now, once we have them combined, we can just do the game we just did, where we're adding 11 to both sides, and we'd get x is 18. Now, try this one if you want, but we're going to put together the guys on the Y team. I've got 8 of them here, minus 7 there. I'm going to have 1 guy on the Y team. Now, the guys who are on nobody's team, they're just numbers. They're going to go together. I've got minus 4 and minus 7. It's minus 11. Now, 1y is just the same as y. It doesn't really do anything. But we can add 11 to both sides. And we get 15. Okay, let's try another one here. We're going to add, the guys on the Z team are the same. There's 6 of them here, minus 5 there. So we have 1 guy on the Z team. We got the numbers. They're not on a team at all. We'll put them together. Oops. Be plus 1. I've got 5, but you owe me 4, so I've got 1 left. Okay, now 1z doesn't really matter. We're just going to do z plus 1 is 3. I can subtract 1 from both sides, and I get z is 2. All right, things are getting more complicated here. We're going to need to distribute this, and so we've seen that I can send him through. I'm going to distribute him to the first one. Now there's like a 1 in front here, so 5 times 1n gets me 5n. Now he's going to go to the 4, and now the 4 is going to act like he owns this sign in front of him. And subtraction and negatives in algebra don't really make a big difference. It's the same end result. So this is going to be 5 times 4, and we're going to get negative 20, or subtraction, same thing. Now we've got minus 4n equals negative 8. So I distributed first. Now, we had to sweep this up, clean it up by multiplying first. Let's get the guys who are on the same team. Well, I've got some n's here and some n's there. 5 of them minus 4 of them here. I get 1n. Now, we don't really care. 1n's just an n. We're going to add 20 to both sides. Now, we've got minus 8, but you added 20. Do you see that's going to be 12? And it's going to be a positive because that was the bigger number. Okay, but if you weren't sure, you can come over here. 20 minus 8 gets me 12. The larger number was the 20. It was the positive. So there we go. All right, we got to do the same thing here. You can always pause it. But I've got to send him through. It's like a 1p right there. So this is going to be 5p. I'm going to send the 5 then there, and it gets me minus 15. Okay, 5 on the p team, minus 4 on the p team. That's 1 on the p team. All right, we're going to add 15 to both sides. Okay, so this is going to be 5, and if you can't see it, you subtract those and you take the sign of the bigger number, which is the positive. Okay, try this again. We're going to distribute here. I'm going to get 4q, and then the 4's got to go to the 2 and get me an 8. Okay, let's tidy this up. I'm going to get 1q plus 8 equals negative 8. Okay, so I've cleared out the 8's. Now, you owe me 8, you owe me 8 more, you owe me 16. Now, 1q and q are the same, so that's our answer. All right, things are getting really messy here. We've got a whole lot of cleaning to do. Let me see if they've done this for us. We had to distribute several times. So we're getting out the broom, we're going to sweep everything up, and what I mean is we got to distribute everything that can. There's 3 of them that need to be distributed. 2 goes there. Now be careful on this 2. He owns this minus sign, so I'm going to send a minus 2 through to each of those. That's how we got here. And I'll show you this on the next slide if there's another one here. Now let's put our same teams together. Now these are going to knock each other out. See, on this side we're going to be left with a y, minus 3. On this side the y's are going to go. Now we're left with what we did. I'll do a full one of these on the next slide, but we're going to add 3 to both sides. And you're going to get negative 1. Okay, now let me work this. Their slides, it's a little too much going on. I'm going to send the 4 through. So I'm going to get 8h minus 12 minus 7h. Okay, so I sent the 4 through. Now, here we send the 6. 6 times 1h is 6h. 6 times negative 2, negative 12, or subtract 12, same thing. Now, here's what I meant on the other one. This 6 is going to own that minus sign. So he's going to come to the h and become a negative 6h. But when he goes to this, I'm going to send negative 6 times negative 1. Remember, subtraction and negatives are the same thing in algebra, so this is going to get me plus 6. A negative times a negative is a positive. Okay, now we're ready to put guys on the same team. Now this is a 7. So over here, let's clean this room up. Let's put anybody on the H's together. I've got 8 of them there, 7 of them there. I've got 1 H. Now over here, I had 6 H's, but I took away 6 H's. Those guys are gone. You've got negative 12 and plus 6. Do you see that would be a minus 6? You owe me 12, but you add 6. Now all we need to do is get H by itself by adding 12 to both sides. Alright, now how do we do this? So do you remember this is opposite sign, so we would subtract and give it the sign of the larger, which is a positive. Okay, pause this and try this one on your own if you'd like to. I'll bring it back up here in a second. I'm going to check to see what we got left. Okay, this is our last one. Okay, I'm going to start working at 2. I'm going to send our 2 through. I'm going to get 10x. Then 2 is going to go to the 2 and make a 4. Over here, we're going to send a 3 through. So 3 times x is 3x, because it's like times a 1. 3 times 1x is going to go there. Negative 6. Now this is the tricky one. The 3 owns that negative sign. So it's like you're sending a negative 3 through. So negative 3x. Now negative 3 and then negative 4. The two negatives cancel each other out and make a positive 12. So he owns that sign. He's taking them with him. Negative 3x plus 12. Okay, let's combine our like terms here. I've got x's I've got 10 x's and minus 9 x's. I've got 1 x left. Over here I had 3x and minus 3x. Those are gone. There's none of them left. And now minus 6 and plus 12 gets me a positive 6. Okay, let's subtract 4 from both sides. And we've got x. I'm not going to write the 1. It doesn't really change anything. Equals 2. Okay, so we're beginning to solve equations here, and the key is we're going to sweep up. We got to do any distributing, any multiplying that needs to be done, and then we need to combine people that are on the same team. Anybody on the variable teams go together, and any loose numbers that aren't on a team at all, they need to be combined as well. And then we're going to get that I don't know all by himself.